Solutions flashcard presented by Gangesh.
Oh,
Right, very
so I
nice.
started with the topic tree.
Hmm.
So first one is types of solution, second one is concentration of solution, and third one is solubility, and fourth one is vapor pressure of liquid solutions, and then fifth one is ideal and non-ideal solutions. Sixth is abnormal molar mass, and seventh one is colligative properties and determination of molar mass. So next, I started with definitions of solution. A solution is a homogeneous mixture of two or more substance. Solute. So solute, a component which present in the small quantity and gets dissolved in the solvent. Solvent. The component of a solution in a large quantity and it acts as an medium in which the solution dissolves. Mass percentage. The percentage of ratio of mass of solute by mass of solution. The mass of solute by mass of solution percentage is equal to W2 by
You can
W.
say W by W percent.
W2 by W by W percentage is equal to W2 by W1 W into 100.
W2 by W
W
into 100. What is W?
mass of solution.
That is weight of the solution.
Volume percentage V by V. The percentage of the ratio of volume of solute by
You can just tell the equation.
volume by volume percentage V by V percentage is equal to volume of solute by volume of solution into mass by volume percentage is equal to W2 by V into 100. Parts per million. Number of parts of solute present per 10 to the power 6 parts of solution.
Why you not written the equation? You must write the equation.
Yes. Mole fraction. Na is equal to Nb by Na. The ratio of number of moles of component to the total number of moles of all components. Mole fraction of solvent is equal to number of moles of solvent by total number of moles of solution.
What is this?
Mole fraction of solvents.
That is called chi A.
Chi A. Molality. Molality. Number of moles in solute by mass of solvent in kgs.
Then that's all.
That's all.
Then what is expanded equation? That we are not expanded formula.
Ideal ideal solution. A solution that obeys the Raoult's law at all concentrations and temperature. Non-ideal solutions. A solution does not obey the Raoult's law at law that all concentration and solution. Positive deviation from Raoult's law. Vapor pressure of the solution is greater than the predicted by Raoult's law due to the weaker intermolecular reactions. In negative deviation from Raoult's law, vapor pressure of the solution is less than the predicted by Raoult's law due to the strong intermolecular reactions.
You must represent this by graph also.
Sir,
Diagram is
I represent in graph. Azeotrope, a mixture of two or more liquids that boils at a constant temperature and cannot be separated by simple distillation. Raoult's law. Pa is equal to Pa naught into chi A.
What is PA now?
Pa is a vapor pressure of a pure component A. Want of factor accounts for association or dissociation of solute particles in solution. Osmosis. The movement of solvent molecule through a semi-permeable membrane from a region of lower solute concentration to higher solute concentration. Osmotic pressure. The pressure required to stop the osmosis. Pi is equal to
I think
MR.
there is some misconcept. See, solvent molecule will be more in the lower concentration, and here it is higher concentration. So from lower concentration to higher concentration, and till what? till both the concentrations become equal. So that too should be included. Then
The pressure required to stop the osmosis. Pi is equal to n
what is pi?
osmosis.
Osmotic pressure.
Isotonic solution. A two solution having same osmotic pressure. Hypotonic solution. A solution having lower osmotic pressure than other solution. Hypertonic solution. A solution having higher osmotic pressure than another solution. And this is concentration, this formula, sir.
The expressions of concentration.
Expression for concentration. So first one is mass percentage. Is it? Second one is volume percentage. Third one is mass by volume percentage. And this is uh, mole fractions. And this is binary mole fraction of a binary solution. And this is APM, parts per million. And molarity. Seventh one is molarity. Molarity. Sixth one is molarity.
Seventh one is molality. Eighth one is molarity.
And solution is liquid solution. Solubility is directly proportional to the temperature. And
What is delta S? Change in entropy.
Change in entropy. Change in entropy is positive in solid and liquid solutions. And the del G solution is equal to del H solution minus T del S solutions. And gas in liquid solution, Henry's law.
What is that delta G?
Gives free.
Gives the free energy of what? Solution.
Solution.
What is delta H? Delta H solution. Enthalpy change. You have to say this is free energy change. Gives the free energy change. This is enthalpy change of the solution.
And Henry's law, Pi is equal to Kh chi I.
What is Kh?
Henry's law constant. So this Henry's law constant is inversely proportional to the mole fraction and also to the solubility of gas. And the solubility is directly proportional to the P and
SP.
Partial pressure.
Partial pressure or vapor pressure?
Partial pressure. And inversely proportional to the temperature, sir. And liquid in liquid solution. Vapor pressure is directly proportional to T. Rolle's law, P is equal to Pi is equal to Pi naught into chi I.
Okay, what is the difference between Rolle's law and Henry's law?
Constant.
The constant varies. Here, Henry's constant. Here,
Pi.
Pi naught. What is Pi naught?
Vapor pressure of a pure component.
Pure component.
Colligative properties. Relative lowering of vapor phase. P naught minus P by
vapor, not vapor phase, vapor pressure.
P naught minus P by P naught is equal to chi P. So the MB is equal to WB by WB into MA by WA into R relative lowering of vapor pressures.
That is nothing but so.
Elevation in boiling point. Del B is equal to KB into M. MB is equal.
What is KB?
KB is molar elevation constant.
What is the other name? Ebullioscopic constant.
Ebullioscopic. MB is equal to KB into WB into 1000 by WA into del TB.
What is MB?
Molar mass of solute.
Solute.
And osmotic pressure. Pi V is equal to MRT.
Forest. Depression of freezing point.
Depression of freezing point. Del TF is equal to KF into M. So M is equal to del TF by KF. So MB is equal to KF dot MB into 1000 by WA into del TF. Electrolytic solution. In that we're gonna see want of factor. Want of factor that represented as I. I is equal to observed.
Where it is applied, this is with regard to the concept abnormal colligative. You must write that one, abnormal colligative property.
So I is equal to observed colligative property by calculated colligative property is equal to normal molar mass by abnormal molar mass. So, um, um, dissociation degree of dissociation is equal to 1 minus I by 1 minus n, and degree of association is equal to 1 minus I by 1 minus 1 by n. The modified equation is B naught minus P naught minus P by P naught is equal to I into chi B, and TB del TB is equal to chi B into KB into M.
I into
I
KB.
into K into M. Del TF is equal to, so del TF is equal to I into KF into M. Depression in P, sir, it's already over.
Freezing point. F for E is the title.
Non-ideal solution. In that we're going to see positive deviation and negative deviation. In positive deviation,
This is a positive deviation. This is a
negative.
negative deviation of the mixer. Next.
Next, azeotrope. Azeotrope, in that positive deviation from Raoult's law. In that minimum boiling points
Of the mixer. Of the
are the
definite ratio.
definite ratios. And negative deviation from Raoult's law, maximum boiling azeotropes.
That's it. Okay. Good. Very good.